the last chapter, you had a brief introduction about data science and data scientists and their job roles. Now in this new chapter, we are going to see about the life cycle of data science process. Like the software development life cycle in software engineering, data science process also has a life cycle. So we are going to learn in detail about the life cycle process of data science in this chapter, and then we will learn about various tools and technologies used in data science. That is, if you want to become a data scientist, you need to know about some IT tools, that is some data science tools, programming languages and some other kind of new technologies. So I will be explaining about these new tools and technologies you need to learn in this chapter, and following that chapter introduction, we will have some installation of certain tools in your computer, and then I will explain about the usage of Google Collaboratory and how to use it. All those will be explained in this chapter. Now we are going to see about data science life cycle. Normally in software engineering, we have the software development life cycle. Similarly, data science also has a life cycle to its process. So in this video, we are going to see in detail about the data science life cycle. In data science life cycle, there are 7 steps: business understanding, data mining, data cleaning, data exploration, feature engineering, predictive modeling, and data visualization. All these 7 steps constitute data science life cycle. So let's see in detail about each and every steps in data science life cycle. Firstly, let's see about business understanding. In this step, we use data science to answer 5 different types of questions. The first one, how much or how many? If we have an answer for this question, then we need to use regression. It is for forecasting how many and how much will be in the future. Then we need to use this regression. There are various types of regression like linear regression, logistic regression, support vector regression, and so many. And if we need to have a category based answer, like if we want to categorize a particular data into a particular setup of categories, then we use classification. If we need to form a group, like we have different kinds of data and we need to categorize these groups into clusters, then if we found that the data is weird, then we use anomaly detection. And which option should be taken? We use a recommendation for the answers based on the questions above. So based on these questions, we get an understanding on how the business data has to be analyzed and the problem has to be formulated and addressed in the initial phase. Next step, we have data mining. We used to have a database to store all the data. We decide on what database and how we are supposed to use this database. Data collection strategies and process. In what way we are getting the data, or in what way we are going to collect the data, all these come under this step. And then we have to decide whether we are going to use SQL queries or we are going to use some packages for data frame like pandas, or we are going to use JSON, JavaScript object notation, or we are going to use some software to store and manage the data. So these decisions are taken in this step of data mining. And then the next step is the data cleaning. This is the most important component of data science life cycle. We also refer this process as data janitor work. So, cleaner the data, better the decisions. More the data gets clean, the decision we take or the decision which is obtained by the data science process will be more efficient. It consumes at least 50% of the entire process. It goes from 50% to 80% of the entire process, and we manage the data type of the values and convert wherever we need. that is the numerical values stored as integer or strings. Like in a database we have a particular value. If it is a phone number or the year of birth, if we mention as an integer and we store it as an integer variable or a string variable, for the processing of data we need to be clear on what data type we are using for that particular data, and then consistent format and spelling for categorical data, whether it is uppercase M in male or lowercase m in male. So we have to be careful with the spelling and the format of the data when we go for the categorical data. So these are all the some basic steps has to be followed for data cleaning. There are so many methods and so many techniques to clean the data, and we have to decide on what and how we have to carry out this process. This process is a time consuming, and it will be like it will occupy almost more than half of the process in the data science life cycle. Data exploration. We need to do a brainstorming on what to do with the cleaned data. In the previous step, we get the data which is cleaner by using the data cleaning. This cleaned data has to be decided on what to be done. And we have to understand the bias and patterns of data. We need to take like the data trends, and we need to analyze on how this pattern of data is going to be. And then we have to analyze a random subset of data and visualize them. We take some sort of subset of data from the main database, and we have to visualize them. Based on this visualization, we have to look for anomalies and outliers in the data's pattern, and then we have to create hypotheses about the data and the problem on how the solution has to be given. So these are all the steps to be followed in the data exploration phase of the data science life cycle. And after the data exploration, we have to go towards a feature engineering. A feature is a measurable property or attribute of a phenomenon being observed. A feature engineering is a process of using domain knowledge to transform your raw data into informative features that represent the business problem you are trying to solve. There are two tasks in feature engineering. They are feature selection and feature construction. So based on these two tasks, we have to decide on how the features has to be formulated and how the features has to be picked from the data we have for the given problem. In feature selection, it is a process of cutting down the features that add more noise than information. So it is also a kind of a cleaning process. It is like the second cleaning of data. So we remove certain features which don't have much significance in having a prediction. This avoids the complexity due to high dimensional spaces. When we have a two-dimensional or three-dimensional data, it is fine. When we go for multi-dimensional data, if we reduce the number of features, the complexity of the problem is reduced drastically. There are three methods. Filter methods that apply statistical measure to assign scoring to each feature. Wrapper methods frame the selection of features as a search problem and use a heuristic to perform the search. Embedded methods use machine learning to figure out which features contribute best to accuracy. So these three methods are used to actually select or to remove certain features from the data to get a proper complexity for high dimensional spaces of data. Feature construction. These are not actually present with the data initially, but we have to create these features from the existing data. It involves creating new features from the ones which are already available. For example, if we have a feature for age, but our model only cares about a person is an adult or minor, we can have a threshold of 18, like in certain countries it is 18, or in certain countries it is 21, or whatever it is. We make a particular threshold and we assign categories to instances above or below that particular threshold. So these categories form as the features which we construct. And then the next step, we have predictive modeling. This is the most significant part of a data scientist. So being data scientist, we are doing a lot of predictive modeling. Predictive modeling is where the machine learning finally comes into your data science project. Based on the questions you asked in the business understanding, this is where we have to decide which model we have to pick for our problem. Like we have a problem and we need to look for a solution. This solution will form like an addressing of various techniques based on the business understanding stage. The model that we end up training will be dependent on the size, type and quantity or quality of the data, how much time and computational resources are willing to invest, and the type of output we intend to derive. Trained model needs to be evaluated for its accuracy using validation techniques like k-fold cross validation. So that is, we have to create a model. So that model will depend on the size, type and quality of the data, and then it will also depend on the time and the computational resources that we are going to invest. That is, when we use like deep learning or something like that, we need to use like GPU based programming. So these GPU based programming definitely require a GPU and some kind of hardware support, and some other softwares may be needed. So these are all dependent on this phase of predictive modeling. And then we use cross validation technique, and there are so many methods. The trained model needs to be evaluated for its accuracy. So for that purpose, we use these methods of validation. K-fold cross validation is one among that. That is, we divide the test data and the trained data into certain number of k shares, and these shares are evaluated with the predictive modeling technique, and based on the performance obtained by these, we get the validation of the given model. The percentage of correct classification is used to measure the accuracy of a classification model. This is for getting the data into a particular category, so that is, it forms as a classification problem. So a percentage of correct classification is the metric which we use to measure the accuracy of that particular model. ROC curves are plotted for true positive rate against the false positive rate. Again, in the classification model, we have certain test data, and this test data is given as positive in the actual label, and the predicted label is also positive, then it is true positive. If the label is false but we predict it as positive, then we say it is a false positive. So the curve which is plotted with true positive against the false positive rate is called as ROC curves, and it is also used in classification models. But when it comes to regression models, that is the value which we may get in the future, we go for metrics like coefficient of determination, mean square error and average absolute errors. These are the metrics which we use to calculate the correctness of the given regression models. So I have given like these metrics used for validating the given predictive modeling technique. So these methodologies will be discussed in detail in another video. So the next, we have data visualization. This combines the fields of communication, psychology, statistics and art. You have to be an artist to efficiently create a visualization. You need to show something that speaks to the people, and then you should have the communication skills that will actually close the gap between you and the non-technical people. And psychology, you should know what kind of information presented by you and what impact it may have on the people. And then we should have the statistical knowledge on how we can present this data. Communicating the data in a simple yet effective and visually pleasing way. So for this purpose, we can normally use a lot of packages and tools. Basically, I recommend using Jupyter notebooks, and they are having a lot of packages for visualization. One such thing is matplotlib. There are so many others. Matplotlib is having a lot of libraries for creating super cool graphs and other kind of visualizations. And there is also like drag and drop tools. The tool like Jupyter, we need to use some Python based code, but these drag and drop tools doesn't actually need any kind of programming. So these tools like Tableau and Plotly are used for data visualization.